What's up? Today we're going to be talking about the coagulation cascade, and it's really actually quite simple. So what I'm going to do is I'm going to put up a main concepts little box, and I want you to write it down. Go ahead and write down what I'm putting up, and as I go through the lecture, just put a check mark next to it as I go through it. That way you can keep, on top of what I'm talking about, and so you can refer to something, one big concept, okay, at the end of it. Before I start though, I just want to give credit where credit's due. I'm getting a lot of it from Dr. Najib. His videos can be found online and on YouTube. And I want to thank my girlfriend Heather, so helping me out. All right. Okay, first things first. In a normal blood vessel, blood is flowing very nice and smooth, and there's no problems. It's not actually done just by itself. Blood vessels consist of live cells called endothelial cells, and these cells release things to keep blood flowing nice and smooth. Okay, so when something happens, when there is an injury or there's something breaks in the blood vessel and there's blood leaking out, these things stop being produced because the endothelial cells themselves get damaged. Okay. So now once that happens, blood vessels start constricting, and then further steps take place in order to ensure that hole gets clogged up. Okay, so first thing, when there's damage to the blood vessel, there is what? Constriction, right? You don't want to lose further blood, but body's going to be like, okay, I'm going to constrict. Second, the injured area, right? The cells in the injured area are going to produce what's known as VW, or Van Willebrand's factors. Okay, I'm just going to put VW factors. Now I'm going to go over this in detail pretty soon, but I just want you to write these down and just put a check mark next to it when I go through it, so you can keep track. All right. Next step, what happens is these things act like hooks. Okay, and now these hooks, they're going to grab onto what? Platelets, right? Now platelets are all over your body, right? The reason they don't form clots in random sites is because they need these hooks and other factors to anchor them down. Okay, so platelet adhesion. Okay, platelets start gluing onto this site where there's a hole. Okay, next thing you're going to have platelet aggregation. Okay, once the platelets attach, more platelets are going to start coming in and sticking together. That's called platelet adhesion. Aggregation. I'm sorry. Then you're going to have the blood coagulating factor cascade, and this involves, factor 5, I think, through factor 12. Not in that order, obviously, but we're going to go into that detail. But this is where the factors come into play in the picture, okay, in the whole total. Once these factors come into play, what happens is this platelet aggregation is not that tight. Okay, so these factors and the thrombin that is finally produced, this is where thrombin comes into play, help glue it all together, and it forms the final clot. Okay, which is known as the secondary clog or the secondary clot. Okay, obviously once this clot forms, it doesn't just stay there. One of three things can happen to these clot. Either it turns into an embolus and just floats off and clogs something else, which is bad. Okay, you don't want that to happen. Or your nearby cells realize that the blood stops pouring out, and there's a stoppage of blood flow, and the hole's clogged up. It produces plasminogen factors and thrombomodulin, and these help dissolve the clot. Okay, and finally, either those two can happen, or collagen and other cells just get laid on top of this clot, and the clot gets subdued. The cell undergoes a makeover of sorts. Okay, and that's what happens. So that way the clot doesn't just build up and stays there for the rest of your life. Okay, so now we're going to go into detail, but make sure you have this and you're checking things down as I go through it. That way you can understand where I'm at. So it's very simple. Constriction. These factors come in, they start hooking up platelets, platelets start aggregating, platelets then attract these factors start coming in together, forms that nice meshwork, nice and tight pack. That's it, you have a clot. It's as simple as that, right? So now I'm going to go and start drawing these pictures so you guys can understand. I'm gonna leave that there. Okay, first things first, what is coagulation? Simple definition. Very good. It's close. It's basically coagulation. All it is you've heard of fibrinogen I mentioned earlier. All it is fibrinogen, which is soluble, right? It's soluble in the blood. Fibrinogen is just floating everywhere in the blood. It turns into fibrin. This is insoluble. So basically, that's all coagulation is. Okay, these fibrinogens floating in the blood, it turns into fibrin, which is insoluble. So it just basically crashes out of the blood, right? With the help of enzymes, which we will talk about soon, turns into fibrin, and this is what glues all the platelets together. Okay, and stops blood from leaking out of the cell. Okay, next thing. What happens when there is damage to a blood vessel? Exactly. So constriction and all that. We already talked about that, right? Now, I'm going to move on from there. Okay, make sure you guys have that. I'm going to ask you another question. Okay. So if fibrinogen can turn into fibrin, and then all these platelets and stuff can aggregate, what stops them from doing that randomly? So what I'm asking is, how is blood not randomly clotting all the time?
They actively produce DNA.
Exactly. You're very correct. So the blood, in the blood, okay, I'm going to draw this picture. There's going to be always things being produced that prevent clotting from happening. Okay, so this is a blood vessel, all right? And like I said, blood vessel is not just some, some random tissue that doesn't have anything going on. It's filled with what? Endothelial cells, right? Just going to draw them here. Nice nucleus. Boom. Okay, and there you go. You have a beautiful vessel. So you have your basal lamina and then endothelial cell. Okay, very basic. So one of the first things that these endothelial cells do in order to prevent clotting is release two things called nitric oxide. Everyone's heard of nitric oxide. And what? PGI2. You know what PGI2 is? Prostacyclin. Very good. Remember, we talked about this. Prostacyclin is a type of what? Icosanoid. Remember icosanoids?
Yeah, I heard that.
Icosanoids, yeah, from arachidonic acid.
Yeah.
COX-1. All right, we're going to go into that pretty soon, okay? So these cells release, it was COX-2. Sorry, COX-2 prevents blood clotting, all right? So anyway, you have nitric oxide, prostacyclin, which is PGI2, and of course, ADP. Very simple, adenosine diphosphate. Yeah, I'm sorry, that's ADPP. So it's adenosine dephosphatase. So it's ADPP. It is adenosine dephosphatase. Okay, not ADP. My apologies. So what these things do is, when platelets try to clot, these things go up, block it from happening. Platelets just go on their merry way. Okay, that's one thing. Next thing is, everyone's going to hear about this. It's called heparin sulfate. Okay, heparin. So I'm just going to draw an H here, and it's going to be situated right on the endothelial cell, and it's going to have what's called antithrombin. Okay, so this heparin acts as a docking station for antithrombin, and basically antithrombin, all it does is it chops up chops up. So say red is for canceling out. So it chops up thrombin and factors 10 and 9. Okay, so heparin blocks, that's heparin sulfate, blocks thrombin and factors 10 and 9. Obviously, thrombin, we talked about it, is what helps form the clot. It helps. It's what helps it's what helps form fibrin from fibrinogen. Okay, fibrinogen is a precursor, and thrombin helps turn that fibrinogen into fibrin, and that's what helps. Obviously, factors 10 and 9 are required for that, and required to aid in the formation of thrombin, and then thrombin is required for that. So obviously, blocking this with antithrombin right here will block that, and thereby block coagulation. Okay, that's the second thing. Third thing that cells have is called thrombomodulin. Okay, it's very similar to heparin, but it acts on 2 other molecules. I'm just going to erase this so you guys wrote it down. This is called, yeah, this is heparin sulfate right here. Okay, it's what binds the antithrombin. And so you have what's known as thrombomodulin. Okay. Let's draw that in blue right here. And basically, thrombomodulin binds to, helps anchor down protein C. Okay, so I'm just going to draw protein C like this. And again, protein C is another molecule that chomps up basically more factors. So factors 5, factors 5 and 8. Further, preventing coagulation. Okay, so this chops up factors 5, 8. Obviously, it's not important to know exactly which ones they chop up, but just to keep in mind what molecules are, helping to maintain that constant, smooth flow of blood. Okay, and finally, you have very important tissue plasminogen activators. Okay, I'm just going to call them TPAs. I'm just going to draw them like a tree. Okay, basically, is TPA, tissue plasminogen activators, and basically what they do is they turn. Once again, I'm erasing this. Like I said, it's not important to know exactly which ones do what, but just to know what molecules help keep blood smooth. And so basically, it's an enzyme that helps plasminogen turn into plasmin. Okay? And now plasmin, guess what it does? Degrades thrombin. Okay, so what are the 2 things that degrade thrombin? We got heparin and we got plasmin. Okay, and what did we say thrombin was needed for? Exactly, thrombin was needed to form fibrin from fibrinogen. Okay, so once again, what this does is it breaks down thrombin into tiny thrombin peptide, basically. Okay, and this is pretty much useless. Okay, it's not used for clotting. And so these are the just 1, 2, 3, 4 mechanisms that the blood uses to keep blood flowing smoothly. Okay, so now these are things that the endothelial cells themselves produce, that they have. Okay, so now when there's an injury, what happens? These things stop going. Okay, exactly. Now we mentioned that the nitric oxide, prostacyclin, and ADPP were produced by these cells. Okay, now if there's damage in the cell, these things have another mechanism. Not only do they prevent the platelet from clotting, but they also help in vasodilation. Okay, so now when these things are released, they're constantly dilating the blood vessel. Okay, so it's going bigger. So now when there's a damage and there's a hole, it's not being produced anymore. Automatically, it's going to start constricting. Okay, so now that's the first step, constriction. Now I'm just going to erase this and draw a new picture and talk about what happens when this is not working properly. All right, let's let's see, I think I'm just gonna, yeah. I'm gonna make it a little bigger though, because a lot of things happen. A little bigger. So, get ready for your checkbox. Make sure you're checking these things as I go through it. First thing I'm going to talk about is constriction. So, and get your pen out. Get ready to check that off. Okay, that beautiful endothelial cells. Yada. Okay, there you go. And the damage is mainly going to happen down here, okay? All right. One cell is a broken endothelial cell. Okay, cell got damaged. There's a hole. Nice wide gaping hole. Blood is leaking out, obviously. Okay, now get ready for your first check mark. Remember we said that these cells produce what? Nitric oxide and prostacyclin. Okay, so, and ADPP, exactly. Very good. Just a quick question. Do you know where these molecules are produced from? Like which organ produces them, mainly? The liver. So all the, the PGI2 and the thrombin and the yada yada yada, all these molecules, most of them are coming in from the liver. So I just wanted to give you that, make sure you understand where they're coming from. All right. So anyway, but yeah, the liver produces them, and then I guess the endothelial cells then release their own molecules as well. But all the other stuff that I was talking about, the clotting factors and all that, those are coming from the liver. So we'll get into that. Okay. All right. So remember the first thing, vasoconstriction. Okay. Get ready to check that out. So what are the three things that cause vasoconstriction in general? Exactly. Obviously, one of the ways is when you have a lack of nitric oxide and ADPP and all that. What's another thing? Drugs do that, yes. But in the body, physiologically, what it does is it uses either a neurologic constriction or myogenic. So either the muscles contract and cause the vessels to close up, or there's nerve impulses which then cause the vessels to constrict. Okay. Let's see. All right. So not only do the cells, not only are they not able to produce these things that keep it open, obviously the cells are not able to produce thrombomodulin, nitric oxide, PGI2, and heparin sulfate. Okay? We already said that. What is that going to do? That's going to prevent dilation. That's going to promote. It's going to promote constriction, and it's going to promote coagulation. Okay? So that's the first thing. Go ahead and check that out. Next thing is the hooks. Remember? All right. So what's going to happen is these cells, they're going to start producing these hooks called von Willebrand factor. Okay, VW factor. And basically, what they're going to do is they're just going to comb into here and make them in blue. Hook, hook, hook. Okay. They're just going to throw them out there. And obviously, you have collagen underlying here and all that. So it's going to hook down to there. And so normally these platelets, they're not able to bind because of the different molecules that we mentioned earlier, okay? But once these hooks are present, what's going to happen? Exactly. There's no NO or ADP to tell them to go away. These hooks have these receptors. They see these hooks, boom, platelets come in and they bind. Okay, that's the initial formation of the platelets. Now this is called platelet adhesion. Okay, platelets adheres, stick. I don't think adhere. There you go, like adheres. Right. Anyway, platelets stick to these this damaged area, and you have the initial formation of platelets. Okay, so once that happens, all right, the platelets start producing vasoconstrictors. Okay, and now do you know a very potent vasoconstrictor? What? Okay, so these platelets. Okay, now this is in the big picture. This is still in. This is step number 2. Okay, this is step number 2. Yeah, which is platelets releasing stuff. Okay, if I didn't mention that earlier, I'm sorry, but step number 2, once the platelets bind, they start releasing stuff in order for more platelets to come in. Okay, so two main things. Okay, the way to remember it, as the famous Dr. McGee puts it, I'm just going to enlarge this. Actually, I'm just going to erase these and make this one large platelet, even though there's multiple platelets bind, just so I can draw exactly what they're producing. Okay. Now the way to remember this is it produces SAC, which is an acronym. Go into what that is, and it produces alpha. Now I'll go into alpha first because alpha is another icosanoid. Okay, and it stands for thromboxane A2. Okay, now that's very important, so keep that in mind. All right, platelets produce these thromboxane A2, and this is a very potent vasoconstrictor. So not only do the the endothelial cells start producing the vasodilators, now these platelets start producing vasoconstrictors. So the blood cell further constricts. Okay, and then you have the sac. Now you're asking, what is a sac? All right, it's very simple. Not SACK, it's just SAC, and I'm going to go ahead and explain to you what SAC is. I'm just going to write it over here and then erase it. So if you want, you can write it down, but it's going to be erased very shortly. S. You know what that stands for? Serotonin. Serotonin. What is serotonin? Another potent vasoconstrictor. Surprise, surprise. And what is A? ADP. I'm going to go into what ADP does, but needless to say, it probably is some sort of vasoconstrictor, okay? C, very important atom, molecule, I guess. Very close, it's calcium. It's Ca, all right, calcium. Okay, now this calcium is very important, and I'm going to go into why that's important exactly. We went over this in the heart lecture, and we mentioned how the calcium is important to me for the contractility of what the SA node. Remember that? All right. Well, obviously you need calcium for you need calcium for bones, all that good stuff. All right. So before I go into these three, I'm just going to go ahead and mention the importance of thromboxane. So make sure you guys have that written down: SAC, serotonin, or you don't have to write it down. If you can remember it, that's fine. It's just serotonin, adenosine, and calcium. Very good. Thromboxane. Okay. Now thromboxane is a potent vasoconstrictor. Now what do we say these endothelial cells release that's a vasodilator? PGI2, right? PGI2 or prostacyclin. All right. So now here's the thing. These two molecules right here, the ratio of these molecules control the amount of blood coagulation and circulation, and basically how smooth the blood is flowing. Okay. All right. So basically, it's a balance. like this here. You know, think of this as like a seesaw, and it's the balance of these two that determine the viscosity of viscosity of the blood, basically. Okay, there's more thromboxane. It's going to be real tight. There's going to be a lot of things. Blood's not going to flow smooth. More prostacyclin. Blood's going to be flowing nice and smooth. Okay, it's going to be nice and smooth. That's good. Now we're going to go into the SAC like I promised. Okay, obviously serotonin, another vasoconstrictor. Adenosine, talk about it. C is calcium. Okay, now calcium is very, very, very important because why? Yeah, calcium is important in the heart, but why is it important here? Yeah, okay, basically what calcium does is calcium helps bind, okay, calcium helps bind the negative residues in thrombin, okay, remember in prothrombin actually, the precursor to thrombin, to the platelets, okay. Now we're going to go into that. Basically, calcium plus 2, okay, it's going to help. Okay, let's say this is the platelet right here. Calcium is going to stay right here. Here's the plus 2, and all these platelets are going to aggregate here. And now this is what gives the signal. Okay, it's like the bats. It's like the Batman.
Bat signal.
Yeah, it's like the bat signal. Getting words. Yeah, you know, bat signal. Anyway, it's like the bat signal. It like flags down the prothrombin to come and bind. It flags down all the clotting factors to come and bind. It says here, look at me, I'm a nice big positive charge. You're negative, come and bind to me. Okay. And so here you're going to have prothrombin, and basically prothrombin is going to turn into thrombin, and this thrombin is going to go ahead and form that final clot. Now we're going to go over that later, but just keep that in mind. Okay, calcium is what helps flag it down, so it's very important. I'm going to go back to the old picture. Okay, so now I told you we're going to go over ADP. Now guess what?
What?
Remember I said once the platelets start adhesing, they do what? Adhering, sorry, they start aggregating, right? What makes the platelets aggregate together?
The ADP?
Exactly. Okay, so remember I mentioned the ADP, so the ADP and thromboxane A2, what they're going to do is the platelets have receptors for these molecules, okay? So they're going to bind to the platelets and bring more platelets in, okay? And so there's going to be like this huge cascade. They're going to start all aggregating, okay? And you're going to have this huge plug right here. But guess what? This plug is not that tight. It's basically a bunch of platelets all aggregated together, okay? Basically there is no glue. And what is the glue? Exactly, fibrin. Okay, fibrin is the glue. Comes from fibrinogen, exactly. And what helps form fibrinogen? Thrombin, right? And the coagulation factors. Coagulation factors and thrombin helps form fibrin. The fibrin is the glue, right? All right. So we're gonna go get into that. All right, doing very good. Okay. Let's see over here. All right. Finally, you're going to have the fibrin that's going to come in and go and do that. Now, before I get into the fibrin, okay, I'm going to briefly, very briefly, go over intrinsic and extrinsic pathway. All right? In relation to coagulation, there are two pathways, intrinsic and extrinsic. All right? I'm debating whether that, you know what? I'm going to go ahead and do that after. Okay, I'm going to go ahead and do that after I talk about good old thrombin and the coagulation factors. Now, here's what you guys have all been waiting for. All the factors in all their glory. Here we go. Let's start from the beginning. Well, not really from the beginning, but you know. Going to start from where we left off in the story, which is basically this huge aggregate of platelets. Now they don't know what to do, and so what happens? Okay, I'm going to talk about the intrinsic pathway first. Okay, I'll go over it later. Basically, you have good old factor 12. Don't ask me why it's factor 12 and not 1. Actually, I know it's why. I know why it is. It's because they figured out factor 12 later on when they figured out number 1. So, but anyway, they figured out that it was actually factor 12 that initiates this whole thing, and now so for us med students, it's a big headache. Anyway, here we go. Yeah, factor 12. It's just floating around in the blood, okay? Was that? Exactly. Very good. So this factor 12 produced by the liver, so just floating around, okay? But when it sees this nice big clot of platelets, and all these molecules that the platelets are releasing, it's going to bind to it, and it's going to turn into factor 12A, or activated factor 12. All right? Now this is basically going to start this cascade of events. That's why it's called coagulation cascade. Okay? Actually, it's called coagulation cascade because of the earlier events too, but this is another form of cascade. Okay? So once 12A forms, again confusing, 11 is going to see that and turn into what?
11A.
11A. 11's going to get activated, all right? 11 sees this, 11's like, oh, hey, there's a party, I'm going to join in. 11 joins the party, gets activated. Once 11's activated, guess what it does? It activates factor 9. Okay?
10's not invited.
Actually, 10 is invited. 10's late. 10's the slow one. All right? So if 12 comes in, it's like, all right, let's go one step down. 11 comes in. 11's like, you know what, let's get bigger. And so, actually, yeah, let's get smaller, but, well, smaller. Anyway, forget that. Forget I even said that. So, 9, and then what? It's 10. Okay, 10's a slow one, but 10 is very, very, very important because what? 10 is the one that actually passes the torch on to thrombin. Okay, so now this is what helps the prothrombin turn into thrombin. Okay, and what does thrombin do?
Helps make the fibrin to fibrinogen.
Very good. So now thrombin turns fibrinogen into fibrin. The good old glue. The good old glue that sticks everything together. Okay? Now, I have a question for you. What helps the fibrin stick together?
What?
I mentioned that fibrin sticks, but something else helps the fibrin stick as well. So, fibrin, I'm going to represent fibrin as this red molecule. Okay, I'm just going to box it out. So, what happens? Fibrin's generated. It's going to go all over this platelet and form this nice big clump. But there's one more thing.
Fibrin's a real part of it.
Exactly. Fibrin's a real party. It just brings everyone together, you know. It's like a cool dude. Alright, so we have, see the cool thing with thrombin is not only does it help in the formation of fibrin, but it also produces something known as thrombin stimulating factor, okay? Thrombin stimulating factor. And now this, once again, helps all the fibrin stick together. Now, if I'm not mistaken, another name for thrombin stimulating factor is factor 12. I'm sorry, no, we're not saying factor 12. I think it's called factor 8, if I'm not mistaken. You can correct me if I'm wrong. Another name, yeah, it's actually factor 13.
Okay.
It's called transglutaminase. Okay, it's called transglutaminase, or what? Factor 13, or
Thrombin stimulating factor.
thrombin stimulating factor. Now, can you tell me what or how this thrombin stimulating factor, or transglutaminase, or factor 13, whatever you want to call it, how it helps the fibrin stick together? This is actually very important. Pay attention. Very important thing. All right. So you got this down. I'm going to go ahead and erase it. Okay. Now before I erase it, I'm going to, remember I mentioned intrinsic and extrinsic pathway? Now, this is the intrinsic pathway, okay? The extrinsic pathway is much faster, okay? Basically, it involves, it involves the tissue factor, okay? That I'll mention that later, but basically all you have is this tissue factor that comes in. The tissue factor starts factor 7, and it turns it into 7A. Factor 7A then goes ahead and activates factor 10. So from here, boom, right there. Okay, so it's very short. Tissue factor activates factor 7. Factor 7 goes to factor 7A, activates factor 10. Boom, you have the pathway. So it skips this whole thing. So extrinsic pathway is significantly faster. Now, going back to talking about what? Transglutaminase or factor 13. Okay, I'm going to go ahead and erase this. Hope this is easy. This was easy, right? Okay, all right, it's good. Hope I made that clear. I apologize. Please feel free to watch it again or watch the great Dr. Najib do his thing on YouTube. All right, so you have what? Transglutaminase. My accent. All right, anyway, transglutaminase or
Factor 13.
factor. Wow, you're very smart. Factor 13.
You say that was such a surprise.
Factor 13. All right, good job. Now, what does it do? It helps fibrin stick. Okay. And let's draw it out. So here's a fibrin molecule plus a fibrin molecule. This thing facilitates it, and fibrin molecule joins another fibrin molecule. Okay. So basically, you have this conglomeration of fibrin, and it helps basically stick. Now, transglutaminase. What is essential for transglutaminase to work? Glutamine, but what vitamin? Vitamin is very essential for transglutaminase.
Okay.
Very good. How'd you know?
I told you my mom has metabolism. I know these things.
Okay, exactly. You're absolutely right. It is vitamin K.
Found in green leafy vegetables.
Found in green leafy vegetables, apparently. All right. So there you have it. Vitamin K, very important in the formation of clots. All right, transglutaminase. Wait, I might be incorrect. Sorry. Gamma carboxyglutamate. Yeah, I'm sorry. That was my fault. That's actually incorrect. Factor 13 has nothing to do with vitamin K. It's actually carboxyglutamate. Okay, not transglutaminase. So it's very important. Keep in mind, it's very confusing. Obviously I got it wrong. So
That's very confusing. You got it wrong.
no. So just go ahead and keep that in mind. So it's not that. All right. So go ahead and erase that from memories. I apologize. I'm probably going to edit this out. If not, then you're going to see it, and then you can just see me embarrassing myself. That way you won't make the same mistake. So anyway, transglutaminase does this, but what's actually involved with vitamin K is something else. Carboxyglutamate. Okay. Now, where is this involved? Which step? Okay. It is involved. Remember, I said that the platelets, they're just floating around. They don't know where to, the factors, they're just floating around. They don't know where to stick. Well, these platelets have these receptors. Remember I was talking about calcium, the importance of calcium? This is where it happens, okay? So you have your platelets, and here is the W factor that's hooking it down. And what happens? You have
calcium on top waving.
exactly. You have calcium plus 2. It's like waving. And now this is where that prothrombin binds. Remember I was talking about prothrombin?
Yep.
Okay. There's prothrombin, and it's binding right here to calcium. Now guess what helps this formation of prothrombin? Guess what's that negative part that binds this calcium?
Vitamin K.
Carboxyglutamate.
Oh, sorry.
Very close. It's actually not carboxyglutamate, it is gamma carboxyglutamate, okay? It's not just any old carboxyglutamate, it is, I always get confused out of gamma. Anyway, it's gamma carboxyglutamate. And here is where vitamin K, very important. So vitamin K, carboxyglutamate, calcium, okay? So it's very important. Actually, it's kind of easy to
What
remember.
does vitamin K do?
It helps in the formation of carboxyglutamate.
Oh.
Okay, and so this actually there's a drug that inhibits the formation of carboxyglutamate basically indirectly. You know what it's called? Warfarin. Very good. Warfarin,
That's why.
aka Coumadin.
Yeah.
Yeah. So anywho, vitamin K is critical for blood clotting. Glutamate. It turns glutamate to carboxyglutamate basically, and that's and the carboxyglutamate helps bind the thrombin. Prothrombin basically to the platelet, and then you have the formation of thrombin by what? What factor? What was that important factor that helps turn prothrombin into thrombin? Which number? 10, right? You gotta remember, just 2 high fives, just think of it like that. 2 high fives, all right? 10, exactly. 10 is very important. Alrighty. And yep, so that was the formation of the secondary hemostatic plug, and as promised, one final note, intrinsic versus extrinsic pathway. It's kind of confusing. You would think that the intrinsic pathway, involves something inside, while extrinsic pathway is something outside, but that's actually not correct. Both of them happen inside. The only reason they're called intrinsic and extrinsic is because they figured out the extrinsic pathway. The scientists figured it out because they took blood out of the cell and they did experiments to it, while the scientists who figured out the intrinsic pathway figured it out because they let blood sit inside somewhere, okay? And so that's basically the formation of the difference between intrinsic and extrinsic pathway. And as I mentioned, the intrinsic involves what? Factor 12, okay? And that's a long pathway. And then extrinsic involves factor what? Exactly. It involves what? Tissue factor. It's not 7, I'm sorry. Tissue. I mean, it does involve 7, but it's tissue.
Factor that starts.
Yeah, tissue factor starts it off. Then it goes to 7, 10, right? And then 10 starts off the whole shebang, the bang bang. And then that's it. There you have it. Cascade. Simple, easy. Have fun.